v0 is plus 40 because it's the positive direction. If I threw it downward, it was minus 40. This is the difference. V final, I don't know. The acceleration, I don't care for the ball. I only look at this. If the positive is this direction, A is always minus 10. Time, I don't know. Again, y0 is plus 60 because I throw it in the positive direction. Y, I don't know. Sorry. y0 is 0. It started here. v0 is 60. V final, I don't know. A, again, I don't look at the ball. I look just at the arrow I chose. If this is the positive side, A is minus 10. Okay, so I write for A and for B, I write the third equation. So y equals to y0, and for A, 100 plus 40t minus 5t squared. This is the position of ball A for every time I want. Okay, if I know the time, I know the position. Let's do it for B. For B, so y equals to 0 plus 60t minus 5t squared. Let's compare them. So 60t minus 5t squared equals to 100 plus 40t squared minus 5t squared. If I do that, sorry. Okay, and take it this way, 40t equals to 100, t equals to 5. So they will meet after 5 seconds. So I know the time. Now let's see where they're going to meet. They will meet at y equals to, I'll put it here, the 5. 60 multiplied by 5 minus 5 squared, which is 60 multiplied by 5 minus 5 times 5 squared. 175 meters. They meet here somewhere, okay? 175. Let's see what happens to each ball when they meet. Vt for A, V final for A is V0, which is 40, minus 10, multiplied by 5, minus 10. Minus 10. Y was 175, 175. So what I know is that it went up and down and then it met him. And for B, V final is 60 minus 10 multiplied by 5, it's plus 10. So it met it when it went up, it didn't go down. Okay, interesting. I want to see it in both graphs. Okay, let's do V over T for both of them, and then Y over T for both of them. Let's start with V. We had T0, we had T5. The velocities, we had 60, we had 40, what else did we have? Minus 10 somewhere, minus 10, and plus 10. Okay. So let's see, let's start with ball A. A started with 40, it finished with minus 10. 5. Okay, this is ball A. Let's see. It started with 40, decreased, stopped somewhere, and then again started to go down, and it met the other ball when the velocity was 10 downwards. Let's see the ball B. It started with 60 and it finished with 10. This is ball B. Let's see why it's okay. The slopes are both the same, they are minus 10. If you do standing, vertical over horizontal, you will get 50 divided by 5, it's 10, minus 10. 50 divided by 5 is also 10, it's okay, minus 10. Areas, let's see. If I want to find this, the value of this point, 2 ways. Understand it. 5 ways, but let's do 2 easy ways. First way is just understanding, because the numbers are good here. 40, it means that every second the velocity decreases by 10. So 30, 20, 10, 0. It will take it 4 seconds to go here. If you want to use the equation, just place 0 here and put 40 minus 10t, and you will get t equals to 4. So it's easy to find this point. Another way to find the point, you can call it t, and you know that 40 divided by t, it's also the slope. So it's 10, or minus 40 divided, because it's minus 10. So minus 40 divided by t is minus 10, t will be also 4. So I showed you 3 ways. Okay, now let's calculate areas. This is a triangle. 40 multiplied by 4 is 160, divided by 2 it's 80. This is 1 multiplied by 10, divided by 2 is 5. It means that it went up 80, down 5. This board went up 80, down 5. If you go 80 and then down 5, you go 75. And exactly this is what it did, because 100 plus 75 is 175. This is a trapezoid. If we calculate the area of the whole trapezoid, we get sum of bases is 60 plus 10 is 70, multiplied by height it's 5, divided by 2, it's 350, 175. Exactly what it did, 175. Okay, so this graph is good. Now let's try to use to draw this one. We had 0 and 5. Let's start with A. A started at 100, finished at 175. But we know from here that it went a little higher. It went to 180 before it went down to 175. Remember, this was 180 because it went up 80, so it's 180, and then back down 5. So how will be the graph? It started here, it finished there, but it was here somewhere. So it will be something like that. Not somewhere, we know exactly where, it was 4 seconds. Now, this is drawing it by just understanding, without using the formula. So why it's in the cry mode? Because the slopes are always, the slopes decreases. Look, the slope was positive 40, then 40, 30, 20, 10, 0, minus 10. Okay, so it's okay. If you want to draw it mathematically, this is the equation for A. If you want to draw this kind of graph, you can find where it meets, just place y equals 0, and you will get these 2 points here, and because this is minus, it's in a cry mode like that. So if we draw it mathematically, we'll get something like that. But I don't care for these points, I just care from here to there. So this I'll wipe off, and I will remain with this. Okay, this is A. Let's draw B. B started with 60, with 0, and it finishes in 175 here. So it must be also in a cry mode, something like that. This is B. Again, if we want to draw it, to understand it first, let's see why it's negative, why it's in a cry mode like that and not in a smile mode. Because the slope here is 60, the velocity 50, 40, until it reaches 10. The velocity, the final velocity was 10, so it was like that. It didn't start to go down, because the starting down means that the velocity is negative, but it didn't go down. It was just going this way. Okay, what else can we can say about this graph? If we wanted to draw it mathematically, we would draw this graph. We put y equals 0, and we'll get 2 points, that one and that one, and the graph will be something like that. But I don't care for this place because it's after the meeting. So from my point of view, I just take this part. Okay, so these are the 2 graphs. Now I want to show you something very nice, a little extra. Look at the velocities. If it goes up 60 and this one 40, this one thinks that that doesn't move and it comes to it with a velocity of 20. Again, if it's 40 and this is 60, this is 20 more. So if we talk relative velocity, which is not our lesson, but just to show you something nice, the relative velocity is 20. Relative means that this one is like it doesn't move, no move, and this one moves with a velocity of 20 towards it. Now look that it's okay. The distance is 100, the velocity is 20, 100 divided by 20 is 5, and they meet after 5 seconds. It's a very big subject to learn relative velocities, but just to show you that there are more ways to solve this problem. Relative means that, just to understand, relative means that you are actually on the ball, you don't know that you move, because what we did here, we looked from the ground and saw, this one go like that, this one go like that, and they meet. We saw the whole procedure. If you talk relatively, it means that you are on the ball. When you are on the ball, you don't know that you go up or down. You think you don't move, and you see this ball moves towards you at the velocity of 20. And the main thing about relative velocity is, if both of the balls have the same acceleration, which they do, -10, it's as if you talk relatively, it means that if it doesn't move, you think it doesn't move, and you see this ball comes towards it, it will always see it in a constant velocity. This is why it doesn't move. It sees it here in the velocity of 20, and it thinks, this ball thinks that the ball does only 100 meters and meets it. But we'll deal with this in another lesson. Just it's nice to know that there are more ways to solve the problems. Okay, I want to show one last thing. One last thing. Because now we know how to approach all these questions. So the last thing I want to show you, what happens if we have another force that changes the acceleration. For example, let's do something easier, just one ball. Let's take this ball with a velocity of 40. Height is, it doesn't matter, 100 meters. And I tell you that there is wind in this direction, that it gives acceleration in that direction of 2 meters per second squared to the ball. Now what will happen? I want to know what's the velocities that it's going to meet the ground and how much time it takes it. The idea is that we know that the Earth is pulling it with a velocity, with the acceleration of 10, but the wind try to move it up with the acceleration of 2. So what we do is we say that the acceleration will be 8 downwards. Instead of 10, it will be 8. Again, Earth is pulling in this acceleration, the wind pulls in this acceleration, so the total resultant acceleration or total acceleration is 8 this way. Now that we know it, we can solve the problem. We'll just write y0, y, t, a, v0, v final. Let's choose, just for the sake of change, let's say that this is the positive direction and this is the origin, okay? Just to practice, and I usually try to use this as positive, but see that it doesn't matter. Okay, y0 is 0, because this is my origin, it starts here. When it finishes, it lands here. Now here, if this is the positive direction, numbers increases this way. So if it's 0, the number will be 100 here. So it finishes at y equals 100. These numbers will be negative. Time will be, I don't know. A is 8 down, but this is the positive. This is the positive ax, so it will be +8. And again, I know that the ball goes up or down, but the acceleration doesn't change. Even though the velocity changes from this direction to that direction, A is always 8 downwards, so it will be always plus 10 downwards. V0 is 40 this direction, but it will be minus 40 for us because this is the positive direction. Okay, let's use the third equation, this one. So 100 equals to 0 minus 40t plus 8t squared over 2. Again, y is 100, y0 is 0, v0 is minus 40, t is t, 8 is the acceleration plus 8. Okay, let's solve it. So it's 4t squared minus 40t minus 100 equals to 0. Okay, so mode 5.3 solves this kind of equation. 4 minus 40 minus 100. So t equals to 12.07, and the other t will be negative, I don't care for it. Let's find the v final. I expect it to be positive because this is the positive direction, and when it lands, it will be in this direction. Let's see. So v final will be, where am I? I'm here. v0 is minus 40 plus 8, which is the acceleration. I'm right, using this formula. 8 multiplied by 12.07. So v final will be minus 40 plus 8 multiplied by 12.07. 56.56. Now let's draw v over t just to see if it's okay. It started off with the velocity of minus 40. It finishes with 56.56. It took it 12.07. It must be straight line because the acceleration doesn't change. If we want to find this point, I showed you 3 ways. Let's talk about them, about these ways. First way, just try to understand. If it's good bad numbers, don't do it. It starts with 40. The acceleration is 8 this way, so every second the velocity decreases by 8. So it started with 40, 32, 24, 16, 8, 0. It will take it 5 seconds to stop. The velocity 0 means stop. Another way, just put 0 here. If you put 0 here, you will get minus 40 plus 8 multiplied by 2. Minus 40 plus 8 multiplied by the time, you'll get time equal to 5. And another way, you know that the slope must be the acceleration, which is plus 8. It goes up, plus 8. So if it's t, 40 divided by something, 40 divided by t must be 10. Must be 8. So t must be 5. So 3 ways to find this problem, this point. Now, if I do slope, it doesn't matter here or there or all the triangle, I must get 8. Just check ourselves. If I do 56.56 divided by 7.07, which is this, it's exactly 8. And if I take this, which is 96.56, and divide it by 12.07, it's again 8. So it's okay. Let's calculate areas. 40 multiplied by 5 is 200, it's 100. This one will be 7.07 multiplied by 56.56 divided by 2, 200. Let's see if it's okay. It went in the opposite direction, 100. This is what it did. It went upwards 100 meters. And then downwards, it went 200 meters and it reached the ground. 1 plus 100 is 200, it's okay. So what we conclude from it, that don't always use G10. Sometimes there is extra data. You have to take notice. And again, it doesn't matter which way you choose positive. the graph and the answers will adjust themselves. Okay, that's for today. Next lesson we'll deal with kinematics in 2 dimensions, which means we throw objects like that, like that, like that, like that, like that. Thank you.